6, it's asked to do an integral using a rationalizing substitution. So remember that when you see that word, all you're trying to do is get a substitution that turns the problem into partial fractions, where it might not have been already. Because if you notice here, if you look at the problem, integral of 1 over 1 plus e to the x, you might think that substitution wouldn't really help you because if you called u anything with the e to the x, you don't have anything to cancel it out. That's actually fine in this problem. You just want to treat it like a normal substitution. So we want to say u equals 1 plus e to the x. Our derivative would be e to the x dx. So if we do our substitution, let's see what happens. We get 1 over u, and instead of dx, we would get du over e to the x. But e to the x from our original substitution is in fact just u minus 1. So we get that. In other words, if I wanted to write this as a fraction, I would say this is 1 over u times u minus 1. That's clearly a partial fractions problem, so let's do that. So 1 over u times u minus 1 is equal to a over u plus b over u minus 1. That tells us that 1 is equal to a times u minus 1 plus b times u. This one's extremely simple to do just by plugging in values. If u equals 1, we get 1 equals b. Well, there we go. That was simple enough because this part canceled out. If u equals 0, we get 1 equals negative a because this would cancel out, which means a equals negative 1. So solving for a and b there, very simple. So this integral is now the same as if we split it up into those there, which is negative 1 over u plus 1 over u minus 1. Each of those is just a natural log. So what we're going to get here is negative ln of u plus ln u minus 1. Finally, we want to put our substitutions back. So remember that u was 1 plus e to the x. So we have negative ln 1 plus e to the x. Or you can drop the absolute value there because 1 plus e to the x is always positive anyway. U minus 1 was just e to the x, so this last one is just plus ln e to the x. But ln of e to the x is just x. So what we're going to get here, if you write it in a slightly different order, we get x minus ln 1 plus e to the x plus c, and that's going to be our solution. So even if a problem, right off the bat, seems like a substitution problem but something's wrong with it, you probably want to do substitution anyway, and then one of your other integration techniques, whether it be partial fractions, integration by parts, trig substitution, will make sense once you've done the substitution. So that's, in this case, when it turns into partial fractions, that's when you call it a rationalizing substitution.